this is Jo from Maths Tutor Me. Today we're doing algebra and we're learning another special product today, which is the difference of two squares. Last lesson we learned about special products which were the perfect squares, which was when we had two brackets next to each other that were exactly the same, that would expand out, and how to expand those out. Today we have the brackets are almost exactly the same, but one has a plus in between and one has a minus in between. When that happens and you do your FOIL expansion, then you'll find that the middle two terms will always cancel out and you'll just be left with the first ones times together to get x squared and the last ones times together to get y squared. Okay, so what I'll do for this first question, I will expand it using the FOIL method just to show you that those two middle terms do indeed cancel. So let's do that. So FOIL, the word FOIL stands for F for first, which is the first x times x is x squared. Then O is for outside, which is x times 3, 3x. Inside, minus 3 times x is minus 3x. And L is for last. Minus 3 times a plus 3 makes a negative 9. Okay, so you can see that a plus 3x and a minus 3x would cancel each other out and there'd be nothing left there for my middle term. So that will always happen if you have got brackets exactly the same, but one a negative and one a positive. So for this question, my final answer is x squared minus 9. Okay, so when you come across a question like that from now on, and you can see that the brackets are the same, you can just simply times the first things together. T times t is t squared, and the last together, 1 times minus 1 is minus 1. Okay, it's that quick, that easy. Question 3, let's do it again. We just do the first ones times together. 5 times 5 is 25. And the last ones times together. Minus z times z is minus z squared. Okay, question 4. Okay, the bracket's the same. One's a minus, one's a plus. So we do 4a times 4a is 16a squared. And then we do the last ones. Minus 3 times a plus 3 is a negative 9. Okay, we're just repeating this over and over. Question 5. 3b times 3b is 9b squared. Then we do the last ones together. 7 times minus 7 is minus 49. Question 6, always check, yes, I've got the plus and the minus, they're the same except for the signs. So 2c times 2c is 4c squared. Then we do 5d times 5d minus 25d squared. And one more on this page, 8m times 8m is 64m squared. And then the last ones together, 3n times 3n is minus 9n squared. Okay, so that's what you call the difference of two squares. On the next page, it's time for you to have a practice. So here's 6 questions, just like the ones that I just did. So pause the video and try these questions and then we'll go through the answers. So question 1. Expanding out using our difference of two squares method. We do h times h is h squared, and then we do the last ones together. 4 times minus 4 is minus 16. So question 2, first times first is j squared, and then last times last, 9 times 9 is minus 81. Question 3, first times first, 6 times 6 is 36. And last times last, k times minus k is minus k squared. Okay, question 4. First times first, 7 times 7 is 49p squared. And then last times last is minus 4. Question 5. First times first, 10 times 10 is 100, a squared. And last times last, minus 9b squared. Question 6. First times first, 12 times 12 is 144, x squared. And last times last is minus 25y squared. So hopefully you're finding those pretty straightforward. The real trick to these questions is when you get all your different types of expanding all mixed up. Then you have to be able to tell what's a difference of two squares, what's a perfect squares, and when do I just have to use FOIL. So join me next time and we're going to do some mixed questions, mixed expanding questions, and there's even some pretty challenging ones in there. So I will catch you later for that. Bye.